Hello, YouTube. This is UMelzo3. In this lesson, I wanted to talk about wrapper classes. And essentially, what it means is sometimes what we need to think about is having an object-oriented representation of a primitive data type. So we're already familiar with ints and doubles and booleans and chars, right? And we have these primitive data types, and we've been working with those ever since lesson 3, when we introduced the concept of variables and we talked about ints and doubles. So essentially, we are already familiar with that. But an int or a double or a boolean or a char is not an object. So sometimes it's going to be helpful to try to basically wrap a primitive data type into an object. So what we're going to do is, if you open up a search engine, what you should try doing, we're going to basically look at it at a special class in Java. And we've already talked about a number of special classes. So obviously we've talked about the string class, but we've also talked about the scanner class and the math class. We've also looked at methods from the integer class. If you remember when we talked about the integer.parseInt and the integer.toString methods in lesson 7, remember that there's a way to convert an int to a string and a string to an int. And those are actually static methods that belong to a class called integer. So now that we understand object-oriented programming, we can go really understand and take a look at what the integer class is and why it's sort of important. So if you go to the Java API, you just Google integer Java API, and it says the integer class wraps a value of primitive type int in an object. So it's basically an object-oriented form. It's like a body that carries an int. Okay, and it's only basically comprised of one field. So when we were creating a person class, we had two fields. We had a name, string, and an age, which was an int. Here we're just going to have an int, and it's, that's the number. It's the number that the integer represents. Okay, and you can see the integer class also has a couple of constants. So if you remember when we were talking about the math class, we said that math has two important constants. We said math.e and math.pi. And so if you write those constants in capital letters, calling them after math dot, then they will return those values. Well, we also have the largest possible value of an int and the smallest possible value of an int. And that's kind of interesting, and you can see that. So if you say system.out.println of integer.min value, that will tell you the smallest value that an integer can be. And it's basically -2 to the 31. So that's a pretty large order of magnitude on the 2, right? So that's a pretty large negative number. So it's kind of neat to be able to see that and just to see what's capable in Java, because honestly, if you try going below that, then there might be an issue. So if you try saying integer.min value -3, you get a positive number. And so you can see that there's strange things happening there. But anyway, let's go back to the integer class and try to get an understanding of what's going on here, because these are the constructors for the integer class. So you could either create an integer object based on a string, or you could create an integer object based on an int. And I want you to go down and scroll down to this method called int value, because the int value method will return the int that the integer object represents. So let's go ahead and try both of these constructors, and then we'll call the int value to add two numbers together. So what we're going to do is we're going to say integer a and b. We're going to declare two integer objects. So declare two, we're not talking about ints, we're talking about integer objects. So it's the object-oriented form of an int. And so we're going to say a equals new integer of 10. But then with b, we're going to use the constructor that accepts a string. So we're going to say 12. And then what we're going to say is we're going to say system.out.println of a.int value plus b.int value. So essentially what this code does is it creates two integer objects according to the constructor, because we said in lesson 22 that a constructor is basically a special type of method that constructs a newly allocated object. Okay, that's what a constructor does. And you can either pass an int into it, which is what we did with A, or a string into it, which is what we did with B. So you have a.int value and b.int value. Well, why are we calling int value? Because int value is a method where if you scroll down here, it returns an int. So we should be able to add ints together, right? and it returns the value of that object as an int. So we'll be able to pull down the 10, and we'll be able to pull the 12 out of here. So essentially now if we go to compile and we go ahead and run our hello world class, indeed we're able to get the 22. So this is a method of a class, and since it's an instance method, you don't call integer dot, you call it on a particular instance because it refers to a particular instance of a class, a particular example object, right? But some of these methods should be familiar to you because in lesson 7 we were talking about integer dot parse int. So you can look at the documentation for this method, right? It talks about parse int and it accepts a string. And so now you see documentation, you see a description here, and it says that it parses the string argument as a signed decimal integer. So it's going to return an integer basically if it's fed a string. And you can see static, right? It says static over here because we call parse int on the integer class, right? Remember we said integer dot parse int. So if you're calling it on a class itself, it's a static method. If you're calling it on a particular instance, it's an instance method. So that's that parse int method that we saw in lesson 7, and you can go review what that does if you'd like. There's also a toString method. So remember when we tried converting an int back to a string. So if we say integer dot toString of some int, that's a static method that belongs to the integer class. So now it would return the string representation of the specified integer. So we've gone back and forth already on that. So we could basically, we've already seen that before. So we could say integer dot parseInt of 200, right? And then you could say something like C plus equals integer, or you could say something like the length of integer dot toString of 5. Okay, and so what would happen here? So dot length, right? So what would happen here? So the 5 is basically so the toString is a static method here. It's a static method of the integer class. So that's why you say integer dot toString of 55. Okay, it would be the same thing as if we had a static method here. So if we have public static int f, and then we just return 2, you could have another integer up here, right? You could say C plus equals, and then you would basically say hello world dot f, or you could just say f if you're talking about the same class. But this is an example of a static method. So this should be 200 here, and then we're going to add on 2, right? We're going to add on 2. So now it will be 202, right? Because 55 becomes 55, and the length of that is 2. So now we're at 202, and then you just add on another 2. So now we're looking at 204, and then if we say system.out.println of C, hopefully that's clear to you what we're doing. But right now we're just sort of demonstrating the functionality of this integer class. And you can see why it's helpful to have a class, because a class provides functionality that an int itself wouldn't be able to provide. That's why we have a wrapper class. We have a class that envelops, it wraps, it's a object-oriented representation of an int. And by having that, we have all this other functionality at our fingertips. So that's why we see the 204 there. And then remember, we were also talking about the difference between a static and an instance method. So what if you say public int f of int x? So now there's 2 differences here. This is an example of an overloaded method, but there's 2 differences. Now we're accepting a parameter, and it's an instance method rather than a static method. So now what if this returns 3? Well, in order to use this method, not only do you have to feed in a parameter, but you would have to create an instance of the class that the method is in. So now you would have to go ahead and say hello world sample equals new hello world. Okay, and you could just call it by default, they always have a default constructor. So you can just say new hello world with empty parentheses. And then you could go ahead and say system.out.println sample.f of whatever you want, because you can see that this function down here doesn't depend on x. So you could say sample.f of 10, okay, and it would know which function you're talking about. And since it's an instance method, that's why we had to create sample. Okay, if you just want to write hello world here, now you have to make this a static method. And since it's in the same class, you could just write f of 10. So hopefully that's clear to you. That's just another reminder of the difference between public and private, right? And here it wouldn't be an issue to make this method private because we're in the same class. So it's all just a review, but I wanted you to be comfortable and familiar with that. But that's the integer class. So you should be familiar with the two types of constructors here. You should be familiar with the int value method, basically just plucking the int back out of the integer object, okay? You could also have a double value. So look at this method here. You could return a double out of an integer object, right? So that should be pretty clear to you, right? So essentially, now if we go ahead and say something like integer p equals new integer of 422, then if you go ahead and say system.out.println of p.double value, right? So it's calling an instance method on p, and double value doesn't accept any inputs, and that's why you have empty parentheses here. But if you go ahead and run p.double value, you should get the 422.0. So hopefully that's clear to you. There's other types of wrapper classes too. So, you know, we talked about 4 primitive data types. We talked about int, double, Boolean, and char. Okay, there's also there's also integer, double with a capital D, the object representing a floating point number, Boolean with a capital B, the object representing a true or false value, and character, the cat with a capital C and spelled out character, not just char. So let's take a look at those. We can go to the double Java API and take a look at some of the things that are available to us here. So we have the double class wraps a value of the primitive type double. And so what we essentially have here is you can have the maximum value, so the maximum possible value of a double, and then you could have the minimum possible value and different things there. And so you can either construct a double either by passing in a double, or you can create a double object by passing in a string, right? And so you could see an example of that here. So we're just going to do an example. So double x equals new double of 3.5 or something. And then if you say system.out.println of x.double value plus 1, then it should be able to handle that. And we know that that would return 4.5 if everything goes as planned. So that would be the 4.5 right there. And then we still had the 422.0 from the previous example. So that's the double value method, and you can see that here. And then there's also there's also an int value. Okay, so there's also an int value. So what would that do? They would just basically run the double value method, but then it would go the extra step of casting it to an int. Okay, and so that's clear enough. So if you say x.int value, this is a method that belongs to the double class. So now if you did 3 plus 1, you would get 4, but let's do 3 plus 1.0, and hopefully we should be expecting to get 4.0, and that's exactly what we see here. So hopefully the mechanics there make sense to you. And then there's other methods that you can be looking at too. So that remember the toString method. So remember, this is a static method. So you might remember when we called double.toString. So you call it on the class itself, double.toString of, and then you put a double into here, and it results in a string. It's a string representation of a double argument. Okay, so hopefully that's clear to you, and then that's essentially what's going on here. And then there's also one for Boolean. So let's look at the Boolean class. So the Boolean class wraps a value of the primitive type Boolean in an object. Okay, and you can take a look at so they have different fields here. So the false and true fields essentially. And you can create a Boolean object either from the Boolean itself or from a string representation. Okay, so you could say something like, we can go ahead and test that out here. So we could go ahead and say something like Boolean B equals new Boolean of true. And then you could say Boolean C equals new Boolean of, and then let's do FAL concatenated with SE. And then it would know what you're talking about with that. Because, as you can guess, the very first method here that you can see is Boolean value. So it would just return the value of the Boolean object as a Boolean primitive. So let's go ahead and write system.out.println of b.boolean value or c.boolean value. So hopefully you would be able to see that if we have true or false, like we talked about in lessons 8 and 9 with the Boolean expressions and Boolean variables, you would be able to see that that's true. And then if we go ahead and let's go ahead and put a not on one of them. So if we go ahead and put on a not on the value of b, Then we go ahead and compile this code and we should get false. So that's an example of a wrapper. It's wrapping a primitive data type. And so there's fewer methods here, right? There's not tons and tons of things that we can do with true and false values, but there's a static method, okay? Boolean dot toString, okay? So what if you wanted to see how long the word false was or something, right? So what if you said something like Boolean x equals the idea that 5 is equal to 300, and then you could say Boolean y equals new Boolean of x, right? And then you could essentially, or you could make a string out of it, right? So you could say, I guess x is already, so x would have the value false. And then what you could do is you could say string y equals boolean dot toString of x, and then you could say system.out.println of y dot length, and then we should be expecting 5 here. So usually that would either return 4 or 5 for the length, right? Because either you're going to get true or false. So there's the 5 there that you see, because that's false. But then if you go ahead and change this to if you change the expression to be true, 5 is not equal to 300, then you would get 4 for a length instead. So hopefully that's clear to you. That's sort of the Boolean class. It's a wrapper class for Boolean values, right? So that's essentially that. There's really not too much to that. And then the last one I wanted to tell you about is the character class. So let's take a look at the character class. That wraps a value of primitive type char, okay? And there's different ones here. There's different ones that you can be looking at. So there's different fields, these different directionality things. I don't know exactly what a lot of this mean, but there's lots of things you can do with characters, right? Because there's all kinds of characters on the keyboard, and they're what make up strings. So they're pretty important to understand how letters work and how Java, interprets them, right? So you could have a character object, and if you look at the constructor, the only way to create a character object is by passing in a char. Fair enough, right? And then you could go ahead and get the char value, right? So you could get a char out of it, right? And if you remember from our discussion of characters, we said that chars get implicitly cast to ints, right? Ints are the only thing that ints are preferred over is chars. So we could go ahead and say character r equals new character of, and then let's go ahead and do it with a capital T or something like that. And then what you could do is you could say int y equals, you could say something like 5 plus r dot character value, because essentially the character value returns a char, it returns a primitive, but we said that chars are implicitly cast to ints, and the reason why there's an issue here is because I didn't spell it right, so it's not character value, it's just char value, right? Because you're getting a char out of it. So then if you go ahead and you want to find the value of y, we could look in an ASCII table, but this would be the ASCII value of t plus 5. Okay, so basically it would be the ASCII value if you were thinking alphabetically, basically go 5 letters further down the alphabet. So if you did U, V, W, X, Y, so we should get the character code of a capital Y if we run this. So if we go ahead and run the main method, we see a capital 80, we see a 89. So if we do ASCII table in Java, and then we can verify, we can look at the character code of 89. So essentially 84 was T, and then 89 would be a Y. It's like adding 5 letters to the character. So anyway, those are the wrapper classes. You should be familiar with integer class, double class, Boolean class, and character class, and why we use them and sort of why they're important here. And of course, the reason why we talk about that is because in the next lesson, we're going to be talking about another type of data structure which only allows objects inside of it. So we can't talk about ints and doubles. We have to talk about integers and doubles with the capital D. So that's enough for now. Thanks for watching, and please subscribe.